Ma'am, I think for the week 8 we have not covered the distribution part.
Sorry?
Yeah, for the week 8, I think we have not covered the last part, the explanation portion of the last part, that is the distribution.
Okay. Did you mention that in the session, last session? Three sessions had happened, right, for week 8?
Yeah, yeah. So for the uh, for the first session, it was just completed till the MGF, and the
Yes, till C. We had
next
gone
session,
till CLT.
in the
Next
next,
session was solve with us, and next was
Next was again doubts from solve with us session questions, madam.
exactly. So
doubt from solve with us.
Yes, ma'am. The other day
It was an
solve.
open session, ma'am. So
Okay. All right. What was the problem and error? Which part?
Ma'am, this one, ma'am. That P less than 5 by 11 or P greater than 5 by 9.
Okay.
Please explain that point once, ma'am.
Okay. So, this is coming from the example Bernoulli
Yes,
P
ma'am.
trials, right? So, the setting was that you have the samples x1 to xn coming from IID Bernoulli P. Okay. And we want to find like the error for uh, Bernoulli P. Okay. So we had three different estimators. One was P1 hat equal 1 by 2. So our first estimator that we had taken was P1 hat equal 1 by 2, P2 hat equal x1 plus
X2 by
x2
2.
by 2, and P3 hat equal
X1 plus and so on
x1 plus
xn
x2
upon n.
plus xn upon
N.
n. And you had x1, x2 up to xn coming from IID Bernoulli P. Okay.
Yes, ma'am.
Now, what is the definition of error?
It is theta hat minus theta.
Theta hat minus theta. Okay. So, what is theta hat here? If you look at the first
It's a
estimator,
function of samples.
it's a function of
Estimator.
samples. Yeah. So, in case of the estimator P1 hat, what is theta hat? What is theta hat here?
1 by 2.
1 by 2. For the first case, it is 1 by 2. And what is theta?
1 by 2.
No, theta is P, right?
It's P.
Because P is estimated, that is unknown.
Ah, yes, P.
So it is 1 by 2 minus P. So this is our error. Now what do we want to find? We wanted to find that what is the probability that mod of error greater than this P by 10 equal to 1. Okay. So error is 1 by 2 minus P. So when you take the mod, you will get 1 by 2 minus P mod, right? And now when you open this, either if you want to plot the graph of this, okay, so you will see that this blue line over here and this blue line over here, this is a graph for mod of 1 by 2 minus P, right?
Yes, ma'am.
And this point is what? This point is 0.5. And this yellow plotting, orange plotting here is for P by 10. Okay.
Yes, ma'am.
So what you wanted your error to be greater than P by 10. All right. So look at these two graphs. So for what reason your error is coming to be greater than P by 10? So any P that is less than 5 by 11 and any P that is greater than 5 by 9 will give you the probability that mod of error is greater than P by 10.
Ma'am, this 5 by 11 and 5 by 9 are given in the question. That, I mean...
No. Okay. Look at this graph. It is 1 by 2 minus P, right? So 1 by 2 minus P is intersecting with this P by 10. So if you do this equal to p by 10, then you will get what? 1 by 2 equal p by 10 plus p, right? And this is 1 by 2 equal 11 p by 10. So from there you are getting p equal 5 by 11. Okay. And now for the 5 by 9, this is coming from this line and this p by 10. So since this the mod of 1 by 2 minus p, this is nothing but minus of 1 by 2 plus p, and you are intersecting this with p by 10. Okay, so you will get p minus p by 10, that is 1 by 2, and this is 9p by 10 equal 1 by 2, and from there you are getting p equal 5 by 9.
Got it, ma'am. Thanks.
Yeah. So you see that for a large value of p, only for a large value of p, your error is coming out to be greater than p by 10, right? Only for a small fraction, like only around this 0.5, your error is coming out to be less than p by 10. Now, similarly, when you see this in case of the second estimator, that is p2 hat, your error is coming out to be x1 plus x2 by 2 minus of p, right? And now if you do the same thing, so since x1, now you have two random variables here, so both of them are IID 01, right? So you can take different cases 0 0 0 1 1 0 0 0, and these are the errors that you got, and these are the probabilities. Okay, is it clear why the probabilities are this?
Yes, ma'am.
Okay, so you will get for 0 0 x1 x2 equals 0 0. Your probability.
Mod of error greater than p by 10 could be 1.
Sorry.
Now, why are we putting mod of error is greater than p by 10?
Okay, why we are putting mod of error greater than p by 10? Because we want to see like why we okay, you know, okay, why is it 1 basically? You want to know why is it 1? Because see, if you look at the first example, you know that like if I give you the error, then mod of error greater than p by 10. Okay, so this will be this probability will be 1 for these value of p. I mean, there is no uncertainty in this probability. We know that this probability of mod of error greater than p by 10 will be 1 if this happens, because this error is fixed, right? The error was fixed here. What was the error? Error was mod of 1 by 2 minus p.
Yes.
Yeah. So you are saying with probability 1 that if p will be less than 5 by 11 and if p will be greater than 5 by 9, your chance that your error is greater than p by 10 is 1.
But
How we got that 1, ma'am?
means it should be the total minus the small region that is below p by 10.
Area between.
Means total is probability is 1, and that should be minus the small region that is just below p by 10. That is within that interval.
No. So this is what? This is equal to probability equal to 1 if this happens. We know it for sure that if p is less than 5 by 11 or p is greater than 5 by 9, probability that your error is greater than p by 10 is 1.
So I think then the event is the interval 5, 11 or p by 9. Probably outside these events.
I'm not able to hear you properly. Can you repeat?
I don't know. There's some trouble with the mic. So the event is that probability 5 by 11 or that is outside the interval. That's what we are calculating.
Yeah, because you can see that except this 0.5 neighborhood, your error is coming out to be greater than p by 10 for these two reasons. Same thing we have done for the second case. So even in the second case, when you try to plot the graph, right? So you have the error minus p 1 by 2 minus p 1 by 2 minus p 1 minus p and the respective errors. So you plot this minus p. You know it will come something like this, right? This is for minus p. Then 1 by 2 minus p 1 by 2 minus p. This mod 1 by 2 minus p. So this will come something like this. Then 1 minus p will come something like this. Then you have p by 10 here. And you get, for each of these errors, you get a point of intersection with p by 10. You see, you have three different reasons here. And your error is coming out to be greater than p by 10 for, this is 5 by 11. This point is 5 by 11. This point is 5 by 9 again. And this point is 10 by 11. So for any p that is less than 5 by 11, and for any p that is that lies between 5 by 9 to 10 by 11, your probability that your error is greater than p by 10 is 1. For the second one, you can plot the graph and check these values. You will get 5 by 11, 5 by 9, 10 by 11.
Ma'am, why are we saying it's less than 5 by 11 or between 5 by 9 and 10 by 11? Why not more than 10 by 11?
Because and that's what I said. You have to plot the graph to say it. Like this graph you have, and your error was minus p, right? So let's say if this is p and this is your error. So minus p is this, right? This is your minus p. This is 0. Then 1 by 2 minus p, and this. You have this mod of 1 by 2 minus p. Then you have 1 minus p. Okay. And then you have this p by 10. This you have p by 10. Now, if you take the intersection of the error with this p by 10, so like you see that the error is this. Okay, this is p by 10 line, right? We have to check mod of error should be greater than p by 10. Okay. And what was the error? Error was minus p, 1 by 2 minus p, 1 by 2 minus p, 1 minus p. Now if you take the mod of all this, so you want the mod of this. So mod of error is basically mod of minus p. Then you have 1 by 2 minus p. Then you have 1 minus p. Okay. I haven't plotted the whole graph here. So minus p, so you'll have this graph. Then 1 by 2 minus p I have drawn over here. Okay. And 1 minus p, it will be something like this. Okay. So we want to check for what values of p your mod of error comes out to be greater than p by 10. This is what you have to check. So you see that this is a point of intersection between this error and the p by 10. Okay. And what is this graph? this graph is 1 by 2 minus p and intersection of 1 by 2 minus p with p by 10. Okay, this comes out to be 5 by 11. So this point is 5 by 11. So any p that is less than 5 by 11, any p that is less than 5 by 11, your mod of error is coming out to be greater than p by 10. Okay, then you see that in this region, here the error is not less than a p by 10. So in what case, sorry, greater than p by 10, it is less than p by 10. So in what case error is coming out to be greater than p by 10? Now you look over here. So in between this region, and what is this region? So it is this point you will get from the intersection of this minus 1 by 2 plus p with p by 10, that comes out to be 5 by 9, and this line, that is nothing but 1 minus p. So when you take the intersection of 1 minus p with p by 10, so what do you get? It is p by 10 plus 1, so 11p by 10 equal 1, so p equal 10 by 11, right? So this point is 10 by 11. So you see that in between this region 5 by 9 to 10 by 11, right? In between this region, your error is coming out to be greater than p by 10. Okay, now again it is less than p by 10, right? Error is less than p by 10. And then after this, after this point, so what is this point? This point is intersection of 1 minus p, no, minus 1 plus p equal p by 10. And what is it? It is p minus p by 10. That is 1. So 10p minus p, 10. So 9p by 10 equal 1, p equal 10 by 9. So that will come out to be greater than 1. So we can ignore this point because p cannot be greater than 1. So from here we got that for p less than 5 by 11 and for p in between 5 by 9 to 10 by 11, your error is coming out to be greater than p by 10.
Okay. Thanks.
Okay, what after that?
Ma'am, here I am confused. Can you again explain?
Which part? Can you tell me?
You take minus 1 plus p is equal to p by 10 from right hand side.
Okay,
Minus p.
because you
is
see
more
that
than-
even here the error is greater than p by 10. So I want to know what this point is for which this p is coming out, for which this mod of error is coming out to be
mod
greater than p
of 1
by 10.
minus. We take
Right?
it is minus mod. We open the mod. We take minus 1 minus p. It is minus 1 plus p, na? But
Yeah,
we
minus
take
1 plus
left.
p.
But we take left hand side 1 minus 1 plus p, na? Here I am confused.
Wait, I will explain this graph again, okay? This part. So let's see.
This is going to positive side, na, ma'am?
Yeah, so what is this point? What is this line? This is minus 1 plus p, and this line is 1 minus p, right?
Yes, ma'am.
And this is 1. Okay, so you see that your p is always lying between 0 to 1, right? It cannot be greater than 1. Now after p greater than 1, like mod of error is coming out to be greater than p by 10. After this, some point that is greater than 1. So we are not interested in that. We don't want P to be.
Okay. Is equal to
So we
1.
can
We take
ignore that.
Okay, ma'am. Clear, ma'am.
Okay. Anything else? Anything else here?
There is a third part also in the question.
Yes, there's a third part also. So, okay, in the third part, you see you have the error, estimator P3 hat equal sample mean. And if you define the error is x1 plus x2 plus up to xn by n minus p. Okay, so now this is no more a small number. I mean, you have n random variable, you're dealing with n random variable here now, and it is not possible for you to go and check at all the cases that your x1, x2, xn takes, and corresponding you find the error. So what do we do in such cases? Okay, so what is your interest? You want to find a bound on the error such that your probability that mod of error greater than p by 10. You want to find a bound on this probability. Okay. Now, what do we know about Chebyshev inequality? We know that for any random variable x, if its expected value is, let's say, expected value of x, variance of x, then we can write probability that mod of x minus expected value of x greater than some delta is less than equal to variance of x by delta square. This we know from Chebyshev inequality. Okay. Now we'll use the same Chebyshev inequality. We'll apply this inequality on error. So initially we had the random variable x. Now just replace your x with error. All right. So what you will get? You will get probability that mod of error minus expected value of error greater than delta. So in place of delta, we have taken p by 10. So greater than p by 10 is less than equal to, this will be less than equal to variance of error by delta square, which is p by 10 square. All right. Now error is this. What is expected value? Expected value will be expected value of sample mean minus p. That is nothing but 0. Okay. Now what is the variance of error? So variance of error will be, so it is variance of the sample mean minus p. So a sample mean is a random variable and p is a constant. So it will be same as variance of x bar. And what is variance of x bar? It is sigma square by n. Okay. So let's put these two values over here. What you will get? You will get probability that mod of error minus of 0. So I can ignore this. So greater than p by 10, this will be less than equal to variance of error. So that is sigma square by n p square. Yeah, here it is 100. All right. Now what is sigma square? You know that your x1, x2 up to xn, they are IID Bernoulli P. Okay. So what is the variance? What is the variance of Bernoulli P? P into 1
P
minus
into
P.
1 by P.
So we can use this here, and what we will get? We will get 100 P square 1 minus P whole square divided by n P square. Sorry, this is P, right? Sorry, this is P into 1 minus P. Sorry. Now what you will get? You will get here P. Okay. So what is this? This is 100 times 1 minus P by NP. So this is the bound that you get on this error. Now from here you can see that as your n tends to infinity, so n is in the denominator here, and as n tending to infinity, your probability that mod of error greater than p by 10 will go to 0, right? Yes. Manan, yeah.
Yeah, ma'am. Actually, I tried to solve a question on finding the number of trials we need to make for a perimeter estimation so that the error would be minimum. So
Okay.
this was a question on activity 9.3
Okay.
of question number 2, where I have to find the minimum value of n such that the error is less than 0.01. So I
Wait.
found it an answer, but it came out to be wrong. So can you please guide me in this question?
Yes, let me check.
Okay, ma'am.
Is it this question, question number 2?
Yes, ma'am.
Okay. So it's the same as what we have done just now. Instead of Bernoulli P, now we have just Poisson mu. Okay. And you have to use Chebyshev's inequality to find the minimum value of n such that probability mod of error greater than under mu upon 10 is less than equal to 0.01. So let's see. What is the delta here?
Root mu by 10.
Root mu by 10. Okay. And what is the bound?
0.01.
0.01. And you know that according to Chebyshev's inequality, your probability that mod of error greater than delta should have been less than equal to variance of error by delta square.
Correct.
Correct? Let's see, wait. So you have probability that mod of error greater than under root of mu by 10 is less than 0.01. Okay. And what you know from Chebyshev's inequality, you know that it should be probability that mod of error greater than under root of mu by 10 should be less than equal to variance of error by delta square. So delta square means mu upon 100. And now see, error is x bar minus, it was mu, right? What was the question? Yeah, mu. Unknown parameter was mu. Now, this is the error. What is its variance?
Mu.
Variance will be mu.
Variance will be mu, right? So just put it here. Yes.
Variance will be mu by n because it's a sample.
Okay, yes. So it is sigma square by n, right? So variance of x bar is nothing but sigma square by n. And what is sigma square? Sigma square is mu by n. Okay. So variance of x bar is mu by n. Now you put it here. So mu by n into mu by 100 is less than equal to 0.01. So you get n
100 by 0.01.
100 by 0.01. So basically n should be greater than this 10 to the power 4.
We are saying that the variance is mu by n because this is Poisson and variance and mean are
Yes,
same.
same. Yes. Is it clear, Manan?
Yes, ma'am.
Okay. Apart from this, anything else? Any other doubt you have?
Ma'am, I asked a question.
Okay, yes. On moment. Yes.
Yes.
We'll go back. Yeah. So your question was how do we find the estimator using the method of moment? Right?
Yes.
So we'll take very simple example first. Let's say your samples x1, x2 up to xn, they are IID Bernoulli P. Okay. And you want so what is the parameter here? P. Parameter is P. Now we want to find the estimator for this parameter P using method of moment. So what do we do in method of moment? We take the first moment. So M1 is nothing but expected value of X. Okay. And what is expected value of X here? It is just P, right? So your M1 is what? This is X1 plus X2 plus up to Xn by N. And this is P. So your P hat MME is nothing but sample mean. Now what happens if instead of this Bernoulli P, let's say I take exponential lambda, then in that case the parameter is
Lambda.
Parameter is lambda. So again the first moment that you equate it to the expected value, and this is nothing but lambda, sorry, 1 by lambda.
1 by lambda.
Yeah, it is 1 by lambda. Now again this M1 is what? Sample mean. This is 1 by lambda. So what you got? You got lambda to be 1 by x bar. So method of moment estimator of lambda is nothing but n upon x1 plus x2 up to xn. This is how you find the method of
Get this when it is generic, ma'am. Can you just look at the problem of tutorial 2, fourth problem?
Tutorial 2, fourth problem. Okay. Right. Yes. Tutorial 2, fourth problem is ML estimator, not method of moment estimator.
For me, it's fourth problem. Can you just open the screen and show?
Okay, wait. Tutorial 2, question number 4. Not this one?
Only,
This
yeah,
one?
this one.
Yeah, okay. So see, here you have a discrete random, x is a discrete random variable, and they are coming from a distribution whose distribution is one is one is coming with probability theta by 2, 2 is coming with probability theta by 3, and 3 is coming with probability 6 minus 5 theta by 6. Okay, now you have taken some samples from this x. So if you take one sampling, what you observe is your 1 is occurring 10 times, 2 is occurring 20 times, and 3 is occurring 20 times. Okay, so how will your sample looks like? So 1, 1, 1, 1 up to 10 times, 2, 2, 2, 2 up to 20 times, 3, 3, 3 up to 20 times. This is how it will look like. Not in the same order, but it will be shuffled 1, 2, 3, 1, 1, 1, 2, something like that. Then you have to find, the first question asks you to find the estimate of theta using method of moments. So in method of moments, what we do, here the parameter is theta. You have to find this theta now. So theta will be, M1 will be expected value of x, right? So can you find the expected value of x from here?
That's where I'm finding the challenge. And what I did was like, since 1 occurring 10 times, I took like theta by 2 plus theta by 2 like that. But actually, I'm not supposed to do like that, right, ma'am, to find.
No, you have to find expected value of x. So the distribution of x is already given to you. Can you not find the expected value of x here?
Yes, I can do like 1 into theta by 2 plus 2 into theta by 2.
Yes, so do that.
My
So
question is, why is it done only because we have 1 occurring 10 times? Why it is we are doing only once? That is my question.
I didn't understand. Can you repeat?
Okay, see, it seems the actual sample looks like 1 occurring 10 times, 2 occurring 20 times, and 3 occurring 20 times in any order, right, ma'am? So my point is, why not we take like 1 into theta by 2 plus 1 into theta by 2? Why are we not taking 10 times instead? We are taking only one
No,
time.
like when you find the first moment. So first moment you equate it to expected value of x. So when you equate this m1 to expected value of x, you will get 1. So expected value of x is theta by 2 plus 2 theta by 3 plus 3 6 minus 5 theta by 6. From there you get some expected value of x, and that will come in terms of the parameter theta, right? Now you have this expected value of x, which is in the form of the parameter, which is as a function of parameter theta. And now you equate this m1, now equate this expected value of x to m1. Okay, so you
I
equate
get that, ma'am. If I use that way, I'm getting it. I'm able to understand that. But my only question is, why are we doing only once? Because expectation of x is like the value of x into its
no,
probability, right?
because this is how you find the method expected value of x. If I ask you to find the expected value of x, you will not go, it is just one random variable. No, I mean, x is just one random variable. Why will you go and look at, oh, this has occurred, 1 has occurred 10 times, I will multiply by 10. No, it is not like that. So when you do m1, when you find m1, that is actually your sample mean, right? M1 is actually your sample mean. So there, this will come.
Okay,
That your 1 is coming 10 times, 2 is coming 20 times, and then you find the sample mean from this information and you equate that sample mean to the expected value of x that you get.
Yeah, got it. When it is distribution mean or expected mean, it is like only, yeah, I got it, ma'am. Thank you.
Okay. Any other doubt?
Hello.
Yes, Siddharth.
Yes, activity 9.8.
Okay.
Okay, but it's maximum. You have not reached up to maximum, right?
No, you can ask your doubt.
Uh, Actually, this question 9.8, question number 1,
Okay.
maximum likelihood estimate of P.
Hmm.
My answer is coming out to be 0.44,
Okay.
whereas the answer given here is 0.5.
All right. Okay. Wait, let me share the screen. Yeah. How did you get 0.44 here? What is also, you have to find the maximum likelihood estimate of P. How, so what is the
So this
likelihood
is
function?
you have to multiply the probabilities, right?
Yeah.
For 3, 0, 1, 2, 3, 2, 1.
So what is the likelihood function?
I'll have to do it. Just a minute. 1 minus P to the power 3 by 3, 0 to P. 3 is coming 2 times. So 1 minus P by 3 square, then 2P by 3 square, then 1 is coming 3 times. So P by 3 cube, and 3 2 is coming 3 times. So 2 into 1 minus P by 3. So it is coming out to be P to the power 5 and 1 minus P to the power 5.
Right. That is a likelihood function. Now you want to
Yes.
find the log likelihood. So
Yes. So
log
5
likelihood
log
what?
P,
5
5
log
ln
P.
P plus 5 ln 1 minus P.
Yes. Then what do you do after that?
So 5 by P.
You differentiate.
Minus,
Yeah.
Minus 5 by 1 minus P.
Yes. Then equate it to 0.
Yes, 5 minus 5P. Okay, right. It is coming right. 5 by 2.
It's coming right, no?
Yes.
Yeah. Must have been some
calculation
mistake. Yeah. Calculation mistake. Yeah.
Just one more question.
Okay.
Yes, tutorial 1, last question.
Okay, tutorial 1. Last question, okay, yeah.
So this gamma 2, they are asking the bias of gamma 2 theta.
Lambda 2 theta.
Lambda 2 theta. So bias of this lambda 2 theta, if you look at lambda 2 theta,
yes,
its expectation is coming out to be n by gamma.
Okay.
And you have to subtract that. To get the bias, you have to subtract it by 1 by gamma. So it is n minus 1 by gamma. It is having a bias, whereas it is in the answer, it is saying that it is unbiased.
Let me check the answer. Is the estimated lambda 2 hat unbiased? So yes, it is unbiased, let's say.
Yes, but if you look at lambda 2 theta, its expectation is n by lambda,
Okay.
n by lambda, and you have to subtract that minus
expectation is coming out to be 1 by lambda, not n by lambda.
N by lambda, n minimum x1 to xn mm. Lambda
Yes.
to theta,
Yes,
Lambda
yes.
2.
That only is n by n lambda. That is 1 by lambda.
How, ma'am? Because minimum of x1 to xn, minimum of x1 to xn is just one quantity, right? So that one
It's one
quantity,
random variable.
it's one random variable.
And
So
that
its
model
expectation
got
is,
exponential n lambda.
so its
Right?
its expectation will be 1 by
1 by
lambda.
n, 1 by n lambda.
How come,
Because
ma'am?
minimum of x1 to xn, this is exponential n lambda.
Exponential n lambda.
Yes.
X1 to xn is exponential lambda, madam. X1 to
x1
xn.
to xn is exponential lambda, but minimum of x1 to xn is another random variable that is modeled as exponential n lambda, not exponential lambda.
So this identity, how can we prove, ma'am? Because I don't know this.
You have studied minimum maximum in week 2, right? Can you try that?
Okay, so the expectation of minimum of x1 to xn is 1 by n lambda.
1 by n lambda. So when you take expectation of n times minimum, it will come out to be 1 by lambda.
Okay. Okay. Right. This I did. I forgot. I just.
Yeah, just try it out. It will be a good exercise for you.
Okay.
Yeah.
And
any other problem?
Here, I think there is just a problem of logarithms.
In ML estimation, yes.
In week 9 tutorial 2, question number 12. Week 9 tutorial 2, question number 12. The logarithms they have taken, I think, are to the base 10, whereas we have to take the logarithm to the base e, right?
Yes, base e.
So answer given is according to base 10. That is why the answer to the base e is coming out to be 0.72, whereas here answer is 1.
Okay, I will change that. Okay, I will write it down. Yeah.
And just one more. In graded, I'm not asking the answer to this graded assignment question. I'm just giving my this question number 10, graded assignment 10, graded assignment 9, question number 10.
Okay.
I believe everyone has a different question, right? I believe everyone has a different value for this question. So should I share what I have got here?
Okay, you can share.
How do I share it? Can I share my screen?
Let me stop sharing it. Can you try now?
Yes, can you see it?
Yes.
This question number 10, it is asking us to calculate estimate of P using method of moments.
So you're saying 1.44.
Yes. P is coming out to be
that is
greater
not
than 1.
possible.
Which means that the probability of 1 is negative, which cannot be possible.
Yeah, it is not possible.
So my answer is coming out to be 1.44.
Okay, if there is an error in this, we will change that. For now, we cannot do anything.
I think that it has something to do because I tried it using that. I tried the same question using this maximum estimation, ML.
ML estimation, okay.
I tried it using ML estimation.
Okay.
And it is coming out to be 2 by 3.
Okay.
So by
No,
ML
for now,
estimation, it is coming out right.
for now, let it be like that, because now we can't change anything. So since you're saying P is coming out to 1.44, which is definitely wrong, we'll have to discard this question.
Okay, but I mean, I should know first whether I am right or not.
No, like if you're finding, if you know your method is right, and if you know your method is right, and you have found P.
All this is so new and this is so confusing that sometimes I wonder whether what I'm doing is right or not. So, so it would be better if you just
cross check,
and then
just
see.
stay or keep there only,
because this is a graded assignment.
So it is 1 minus P by 2. Then you have 2 times P by 2 plus 3 times 1 minus P by 2 plus 4P by 2. Okay. So you got 4 times 1 minus P by 2 plus 6P by 2. There 4 minus 4P by 2 plus 3P. So 2 minus 2P plus 3P. So P plus 2. And P by 2, we are saying it is 4 occurring, 1, 2, 3, 4, 5, 6, 24.
31 by
plus 6 plus 7. Yeah, so 31 by 9. So P should be 31 by 9 minus 2. Yeah, it is not coming to be less than 1.
So I'm right, ma'am?
Yeah.
Okay. I think everybody gets a different value for the different numbers for.
Yeah. Okay.
Everybody gets different numbers, so maybe the numbers which I got.
Or some people might be correct.
It's
possible.
Okay.
Okay.
So that's all I have.
Okay. Yeah, I can stop sharing. Anybody else?
This week is very rigorous. Actually,
lot of content.
Lot of content is there, and there is additional lectures also. How important are these additional lectures, ma'am?
Additional lecture, you have this confidence interval part.
Yes.
If you are interested, you can watch. Otherwise, it's okay. Then actually the course will get more rigorous till week 12 as you move to week 12.
Okay.
So from here, week 9 estimation, again week 10 you will see Bayesian estimation. Then week 11, 12 we will see hypothesis testing. So there's a new theory and it is little rigorous.
So this minimum which you are talking about, minimum of
x1 to x3, yeah.
x1 to xn lambda, xn to xn exponential is 1 by n lambda. That proof is given.
That proof you might find it on Discourse, but on the portal it is not there. So you can use your what you have studied in week 2 to prove this.
Okay. So if I have n exponential IIDs,
then it's
if you find the minimum, its minimum expectation is 1 by n lambda. If one IID is lambda.
Yes.
Okay.
Anybody else? So all of you know how to design your estimator using the two methods that is given in the lecture. That is method of moment and maximum likelihood.
Ma'am, just one question I have. Suppose it's a continuous variable and we are using maximum estimation. I don't forget the name of the method. ML method is?
ML method is you
What is the full form of that?
Maximum likelihood.
Maximum likelihood. And
Yes.
we have a continuous variable. And for the continuous variable, the PDF will be given.
Yes, the PDF will be given to you. Yeah.
So we have to multiply. The PDF is not actually the probability, right? PDF is just the density.
PDF is just the density.
So we have to multiply the densities together. Suppose we are given x1 to xn IIDs. We have to multiply the densities together.
Yes.
Suppose,
yeah.
But they are densities are not the probabilities, no, ma'am. So how can we multiply the densities?
Yeah, densities are yeah.
For discrete, it is understandable that if we have got a sample x1 to xn and we are multiplying the probabilities to get that I can understand. For example, this question which was there, graded assignment 9, question number 10, it was a discrete variable and we multiplied the probabilities to get the probability of this sample taking place, this particular sample taking place. But in a continuous variable, are we supposed to multiply the...
See, let's say we have the continuous random variable to be, let's say, exponential. Okay, let's say it is exponential lambda. X is exponential lambda. Now, if you have to find what is the probability that x equal 3, what do?
Probability that x equal to 3. So we have to multiply.
X is exponential lambda.
We have to integrate that with respect to dx. We have to multiply the PDF with respect to dx. Whatever PDF it is, we have to integrate it with dx to get the probability, right?
Yes.
From the PDF, if we want to get the probability, we have to integrate, right, ma'am?
We have to integrate,
So how just by multiplying the densities we can get the probability of a particular sample occurring? I mean, it's a graded assignment question. No, it's not graded. Just a minute. I'll just show you one of the questions here. Yes, ma'am. Yes, ma'am. This is week 9 tutorial 2 question number 5.
Wait, I will just check.
This is a Rayleigh distribution they are saying, and I believe this is a continuous variable and PDF is given. Rayleigh distribution.
Rayleigh distribution, okay, wait.
And PDF is given, and there are 5 samples which are given, 3, 5, 7, 4, and 6. Now, for each of these 5 samples, we have to substitute x in the PDF and multiply.
You have tutorial 2.
Tutorial 2, question number 5.
Yes.
So this is a continuous variable.
This is a continuous
and
variable.
PDF is given for this. And there are 5 IID samples from this continuous variable, 3, 5, 7, 4, and 6. So for each of these values, we have to substitute x into the PDF and multiply the PDFs together.
Multiply the PDFs together.
So by multiplying PDFs, how can we get, ma'am, the probability?
Like when we
PDF is not
find
the probability, right? It's the
yeah, it's a
density.
density function. Yeah.
So we are supposed to multiply the PDFs. For discrete, it is understandable. We multiply the probabilities, and because they are independent, we get the probability of that sample occurring. But in case of continuous distribution, we are supposed to multiply the PDFs. How multiplying the PDFs will get us the probability?
Multiplying the PDFs.
For example, here, how will you do this question? You have to substitute 3 into the, suppose x equal to 3. You have to substitute and find the fx. Then you have to substitute 5 and find the fx. Then substitute 7 and find the fx. 4 and 6 and find the fx. And multiply all the fx together. And that is how you will get the estimator function. And then you have to find the logarithm and differentiate it to get the answer. That is the method given in the lecture, right?
Yeah,
but
that is how we find it.
But my question is, how can we multiply the densities together? And multiplying the probabilities, I can understand. But multiplying the densities, how it is?
Multiplying the densities. Wait. Let me think about it.
But the method is right, na? That is how
method is right.
So you have to find the PDF corresponding to each of these values and then multiply all the PDFs together.
Yes.
And then find the logarithm.
Method is same. You find the likelihood function, you find the log likelihood, then you differentiate with respect to the parameter and you find the parameter. That's the method.
Yes. So that is one doubt I had from this week.
Okay. So you have watched all the lectures?
I have tried to, but I had this what do you say, exam also today. That
OPP
exam was also there, so I couldn't very rigorously watch all the lectures, but I tried to at least solve the questions based on whatever I could see in the notes.
Yeah.
But I cannot say that I have understood everything.
It's okay. You can still watch after some time.
But deadlines are there, so you have to complete it, right? Otherwise,
yeah, you'll have to complete it.
Because that's why I tried to complete. I tried to solve the questions at least, so that my deadline does not get missed.
Yeah.
I tried to watch all the lectures, but the additional lectures are not that important, because that is where actually the probability comes to. Actually, I thought that the estimation, what was that?
Confidence interval.
Confidence interval is what we use in our academic activity at our college. So is it not important? Is it not important?
No, it is important. But since the content was a lot for this week, we have decided to put it in additional content.
And they have talked about a T distribution also there. T distribution.
T distribution you will again see when you go to hypothesis testing.
Okay.
Yeah.
So it is. They said it is somewhat like normal distribution, but its formula is different.
Yes.
So that is that. So should we watch it? And because there are questions related to that also, activity question 1 and activity question lecture 2.
No,
Questions
it
related
is
to
an
that are also there in
it is
the.
an additional content, right?
No, but the last activity question lecture 1 and activity question lecture
Yeah,
2,
that they are for additional lectures, so you
they are
don't have
based on that only. So I
yeah.
thought that they may be
No,
important.
we have provided the question. So initially that content was not an additional content. Since the content was too much, we have put few things in additional content.
Okay.
Yeah. Initially everything was in the content only.
Okay. And that Chernoff,
Chernoff bound, again, that is an additional content.
okay. So it's very difficult to determine what is important and what not, because that I honestly don't remember learning that n IID exponential samples, minimum of that is 1 by n lambda. I
Yeah,
don't
it has
remember.
not
I don't remember.
it has not been done before, but you can try it.
Okay. I think it was minimum for geometric was there. Minimum for geometric was there, but not minimum for exponential.
Yeah, it was not there.
Minimum for geometric was there, but minimum for exponential. So that one thing we have to remember, that minimum of that is 1 by n lambda.
Not minimum of the random variables that
IIDs and IIDs.
yes, that is exponential and lambda.
Yes. Exponential and lambda, yes.
Yes.
And regarding this risk, madam, generally in the questions, how they find the risk is first they find the bias, and then they find the variance, and then using the bias and variance they find the risk. Is there a direct method to find the risk?
So what is risk? Risk is just the expected value of this
Theta hat minus
theta
theta.
hat minus theta whole square. So you can do that. That is also a way to find the risk. So since you already, if you have to find
in most of the examples, first they find the bias, then they find the variance, and then they add the variance to the square of the bias to get the risk.
But you can always directly find it. I mean risk, because you already know the formula.
I tried that, but it is very difficult because.
Yeah, in some cases, yeah, because after you're doing square there.
Yes.
Yeah. So this comes a little handy when you have to find the risk.
In this ML estimation, we first talk about whether what type of distribution it is.
Yes.
If we know the distribution, then we can find the ML.
Yes.
Right?
Yes.
But suppose the distribution is not known, then ML cannot be used, right, ma'am? If distribution.
Then in that case, yeah, it's to find the ML estimator, you need to know the distribution. No?
And many times ML and moments
gives the same.
Give different.
Many times it gives different. And many times it gives the same also.
So which one is correct? I mean,
Both are many people use ML estimation, many people use this method of moment estimator. So both are good actually.
Okay.
Yeah.
So if we have some data.
So like you already know the error part. So one thing can be done is you design your estimator using any of the method, and then you check which one gives you the least error, right? So that can also be a good metric to check which one is good.
Okay. Which gives the least risk.
Least risk.
Yeah. Because error is not reliable, right? Because sum of error can be
0.
Okay, thank you, ma'am. I have asked most of the questions which I could. But is there a extra session going to for this week? Because
Yes. There will be one more session.
Okay, and that will be solved with us.
Yes.
Okay.
That will be solved with us.
And quiz 2 will be based on which weeks, ma'am?
Week 5, 6, 7, 8.
Not 1 to 4.
Not 1 to 4. It will be 5 to 8.
Okay. Okay.
Okay. Anybody else has any doubt? Nobody has any doubt?
Ma'am, tomorrow is also there is one session, so it will be solved with us or it will be open discussion.
Sorry?
Tomorrow also we are having one session.
Okay.
So it will be solved with us or it will be also open discussion?
No, it will be solved with us.
Then on Tuesday also we are having one session from 8 to 10.
Tuesday also there is one session.
Yeah, the calendar is showing such.
Wait.
Actually, calendar, it says today's is activity session and tomorrow it's open session, and on Tuesday it's solve with the session. That's how the calendar says.
All right. Okay, we'll update that.
Okay.
Yeah, thanks for informing.
It's like tomorrow we won't have session. No?
Tomorrow you won't have session. You have any doubts?
Actually, ma'am, could not complete all the lectures, so presently I have completed only 4 lectures. So
okay. Any doubt till there?
No, ma'am, not. because I could solve the activity questions and the slides were quite clear, and the doubt
Okay.
which you discussed earlier made it very clear.
Okay, okay, that's good.
Ma'am, one suggestion is there.
Yeah.
Like we are having the activities, extra activity sessions, and in that we are finding out something and something. So if we could have one session which whatever we are learning in the week and we are utilizing to find those parameters from the given data, then I think so it would be more clear how you have to use whatever you are learning.
You want to have some extra activity on what you are learning in the lecture, is it?
Yeah, something like a hands-on experiment like thing.
Okay, like can you give some examples?
For example, in the current week, we are finding out the estimator, we are finding out the parameters of the distributions using different concepts, different methods. We are finding out the error, risk, and all that bias things. So, what I'm suggesting is that if suppose we are having some data in an Excel sheet, and now you apply this concept that how first of all you are getting the error now. How
There is one activity based on that, isn't it?
I think so.
Method
It's
of
extra
normal.
activity is 6 is there. I think.
6 is continuous distribution, I guess.
Actually, I could not see that details view for that activity. That is why I'm not
But
sure.
if I remember, there was one extra activity which was related to finding the method of moment, maximum likelihood. It's extra activity 6.
We had extra activity 5. That only is about distribution.
Okay.
That says about finding.
Yeah, so you can actually put this suggestion somewhere to record, like what exactly is your idea. It'll be good if you can put it somewhere.
Ma'am, the reason for suggesting is that sometimes what happens that whatever I have learned in the lecture, I'm quite not confident whether my learning or my thought process are same. And if we do some like we are doing in Solve With Us, we are solving the questions in a live sessions. So we come to know that our method is correct or not.
Yeah.
And somehow so what happens is that sometimes you get the answer, but our methods are different, and we are getting two different approaches to get the solution. That is also one of the reason. So by doing some exercise, what happens is that we are getting more clarity or what is actually we are learning and how we can implement in the real life scenario. So that is why I'm suggesting this kind of activity.
Yes, that this is the same reason extra activity was introduced in stats too, so that at least
that extra activity, what happens is that the students are doing on their own, but we are not getting that is suppose, because it is possible, quite possible that the data which we are procuring is not giving what exactly it should be desired. So in that scenario, if there is a data from your side and we discuss in the live session that, okay, now this is the data. So first of all, what method you can apply?
Okay. You mean in the live session?
Yeah.
Okay. We can try to do this.
Because what happens is that there are different ways to analyze the problem. Once few people use the Excel sheet. So in Excel also, you're using Google Sheets, you can use the Explore function to find out some information. Then there is another is that using the Colab notebook. So in Colab notebook, this way you can proceed, and you can find out the moments, you can find out what the variance and all that stuff. So two different ways are there. So basically the idea is so that how you can simulate the things and get the solution to the real life scenarios.
Yes. Yeah, that can be done.
Okay, ma'am, that's was my question.
I will keep in mind. Yeah.
I did this Maths 1 course some time back.
Okay.
And in this maximum estimation, maximum ML method, they are asking us to find the we have to differentiate that function and equate it to 0. But it can be a minima as well as a maxima, right? When you equate it to 0,
it can be.
It could be a minima also, and it could be a maxima also, right?
Yes.
So it's not necessary that it will be a maxima only. From what I can recollect from Maths 1.
Yeah, that is right.
If you equate it, if you differentiate the function and equate it to 0, we might get we are getting the slope of the line as 0. That means that it could be a maxima also, or it could be a minima also.
It can be, yeah.
So why are we saying that it's always a maxima?
So what do you do to check the maxima or minima? You double differentiate it, right?
Yes. You double differentiate it.
You can try to double differentiate everything and see.
If you double differentiate it, then in case of minima, you should get a positive value, is it not? You should get a positive value in case of...
Yes.
And in case of a
maxima, you should get a minimum value, yeah.
Actually, I forgot everything about Maths 1 now. Maths 1 when they...
So differentiation you have studied in Maths 1?
Yes.
Even integration?
Yes.
Okay.
So, at that time, but what I recollect is that if you equate it to 0, it could be a maxima also, it could be a minima also.
Yes.
And that's what you are now telling me to double differentiate it. So I remember that by doing the double differentiation, we were differentiating whether it was a maxima
or minima.
But sir never talked about double differentiation in his lectures here.
Yeah, because it gives you the maxima. Just check, take few examples and check.
Okay.
Yeah. If nobody has any doubt, can we close the session? Or do you want to discuss something?
Ma'am, is it possible to discuss solve with us for week 8?
So yeah, we can do that.
Actually, I'm having doubt in question number 3.
Okay. Yeah, here. This question.
Yes, ma'am. In the solution that is discussed, It is saying that xi follows the gamma function 1 comma 1. I'm not getting that how
Yes.
this 1 comma 1 came.
Yeah, because you see, if you write this x to be x1 plus x2 plus xn, okay. So what you're doing here, and what was x? X was gamma n comma 1. So if you, there is a property that says if you add n IID's gamma distribution, it will give you, so like if you have x1, x2, xn, that follows IID gamma alpha beta. Okay, that follows a gamma alpha beta. Then if you sum these random variables, so if you do x1 plus x2 plus up to xn, then that will follow gamma n alpha comma beta.
That property is clear.
Yeah, that is clear, right? Now, in the question, it is given that x follows gamma n comma 1. So what we have done is, we have written x to be x1 plus x2 up to xn.
Okay.
Okay. And if x is written, and you know x is gamma n comma 1. So if I'm writing x to be x1 plus x2 plus xn, it means all of these xi's should follow gamma 1 comma 1, right?
Actually, that part was only not clear. That is why this similar question was there in the graded. So I somehow got the answer, but I was not confident whether it is correct or not. That is the reason I asked.
Okay, okay. Yeah.
Thank you, ma'am.
Yeah, thanks. Okay, anything else?
Ma'am, will any revision session for quiz 2 will happen next week?
Yes, it will happen. It will get scheduled in the calendar. Yeah.
So mock will also be there.
Mock will also be there for quiz 2, yes.
Actually, ma'am, if you think about the problem, then it's easy to solve it. But time bound in the exam, if you try to solve it, it takes a lot of time. In the first exam also, we faced time crunch.
So how much time did it take to solve the problem?
I could just manage to solve in time. But
okay.
after fifth week, it is taking a lot of time to understand the question first, and then firstly understanding the question itself takes time. Then solving it does not take time, but understanding it takes a lot of time.
Yeah, you can practice more and more questions so that when you see a new problem, it's not so difficult to understand. That will definitely help. Because number of questions are 10 only in the exam for 1 hour, and
10, no ma'am, 18 or there is something.
No, it was 14. 10. No, I mean, if you include the subparts, then it is 15.
Okay.
Yeah.
Actually, last time mock was easier than the quiz, ma'am. Maybe
mock was. I think maybe mock you get a lot of time to solve it, so you can try like next time when you get the mock, like try to time it and solve. Sit for 1 hour and see how much you are able to do. I think that will be useful. Then you will know like how many questions you are able to solve in 1 hour. Okay, anything else?
Ma'am, just one request from the team that please upload the solutions after the deadline as and when it is get completed.
Yes. We will take care of that. It has been told to upload, but we will check what happened there. Yeah.
because what happens is that many times we, just as I have said before, many times we solve the question, but to know the
And we
correct
don't,
approach,
yeah, I can
it is better
understand.
to.
Yeah. Yes.
And generally, sorry to say that, but in stats too, the things are getting uploaded very late.
Okay. Okay. We'll keep a track on that.
Okay, ma'am.
Yeah. Anything else? Okay, so we'll close the session for today now. Since none of you has any doubts, we'll meet again on Tuesday.
Okay, ma'am.
Yeah. Okay. Thanks all.